I'm John Papa.
And I'm Anders Heilsberg.
And today we're going to talk about the 5 coolest features in TypeScript. Number 1, we can get type checking even in JavaScript?
Yes, you can.
How?
So TypeScript's language service is all written in TypeScript and in JavaScript, if you will. And JavaScript is, in a sense, just TypeScript without type annotations. And so we can use the TypeScript language service to analyze JavaScript because we have very strong type inference in the TypeScript compiler. We can actually infer a lot of the types even though you had no type annotations at all. Or if you write JSDoc annotations, we can slurp up the JSDoc annotations and feed them into the type checker and use those to check your code. So we have this mode for JavaScript called TS_check, or we have a directive you can put at the beginning of your JavaScript file called @TS_check in a comment. And then we will run the type checker on your JavaScript file. But we won't report as many errors as we perhaps would have done in TypeScript. You know, in TypeScript, sort of our mantra is, well, if we think something is wrong here, we should give you an error, so you can go check it. In JavaScript, on the other hand, it's more like, well, if we're not sure, then let's just leave it alone. But if for sure we can tell this is not right, then let's give you an error. And it's remarkable. You just try and fire it up on a plain JavaScript file. And I mean, time after time, I've heard people say, oh my God, it just found a couple of bugs right out of the gate and I didn't do anything. You know, and there's really no harm in doing it because you don't have to modify your code at all.
And that's relatively recent, isn't it?
It's fairly new. It's in Visual Studio Code. And I don't think I forget if it's turned on by default now, but you know, it's one configuration file setting, check.js, you set that to true, and then we will automatically check every file in your project. Or you can individually opt in by putting a //@TS_check directive at the beginning of those JavaScript files you want to have checked.
Number 2, I want to create variables, but I want to constrain them to certain domains, like have a string that's like yes or no.
Right.
Can I go there?
You can with literal types or string literal types, and we also support numeric literal types and Boolean literal types. In fact, our TypeScript's type system is pretty advanced compared to like type systems like, say, C# or Java. We have concepts like literal types and union and intersection types that, in a sense, are more like functional programming than your sort of classic type systems. So you can express a type that is a string or number, for example. Or you can express a type that is, quote, yes or, quote, no. And only those 2 string literals qualify at that point. But of course, a yes is assignable to a yes or no, but not the other way around, right? And so there's a whole bunch of checking that we could do at a very granular level.
A lot of times in JavaScript, I would have an array, or I'd want an object. Maybe I'm getting an array of those objects or a single object. So I could use that with unions?
Sure. You can have string or string array, for example, as a type. And then you can dynamically check if X is of type string, you know, then we know you have the string, otherwise you have the string.
Number 3, undefined is not a function. I get this a lot. Help me.
Who does not get that a lot? Yeah. This is like, who has never had a null pointer bug, right? I mean, even in languages like JavaScript. TypeScript 2.0 introduced the ability to check types for null. And it sort of leverages many of the things that are in our type system. One is union types that we just talked about. In strict null checks mode, we basically say that the values null and undefined are not part of any type unless you explicitly make them part of the type. So if you say string, that means a string, but not null or not undefined. But if you want to include null or undefined in the domain, then you say string or null, or string or undefined, or both of them. And then the type checker will check your code accordingly and effectively identify places where you have not yet guarded by checking for null or undefined before you do an operation that would blow up.
Number 4, how does TypeScript help with control flow analysis?
So control flow analysis is this idea that the compiler will check what happens to the type of a variable through the flow of a body of code. Say, for example, you have a variable that can be string or undefined. Let's call it S, okay? And now let's say that you write an if statement where you say, if S not equal to undefined, open curly, well, in that block, we know that S is not undefined. So we can actually dynamically change the type of S. So S will appear all of a sudden to just have type string within that guarded block. But in the else statement, we know, of course, now, well, then string S must be undefined. So in that part of the code, S would have the type undefined. And so it's, in a sense, the ability to dynamically change the type of variables based on the expression constructs that surround those variables. And it very well, it harmonizes super well with the way that you think about your code, right? Because you know that I just said if S is not equal to undefined, right? Of course it's not undefined then. You know, and of course I don't need to then like get an error about nulls or whatever. And that's how you guard your code. And the process of doing that is called control flow analysis. And it basically is based on the compiler knowing what every statement construct does to every variable. And of course, it goes deep into patterns like the and the or operators and the like type of checks. You know, if type of x triple equals quote string, now we know that x is going to be a string in here. We can also give you an error if you try to check against something that x couldn't possibly be. You know, for example, if you've already checked whether x is a string and then you later in the code try to check again, we'll just tell you you already checked that. So.
So it gives us more help with the tooling to let us know in the editor that these things are going to be used in a certain way.
It's really sort of the next level of type checking, right? Where, you know, this is the key enabler for null and undefined and non-nullable types. You know, we could not do that without control flow analysis because it would just be a major pain in the neck if we did not narrow the type of your variable after you have excluded null or undefined. Do you know what I mean?
Yep.
So it's like this symbiosis of union types and control flow analysis that give you the ability to have non-nullable types, if you will.
Number 5, Pyramid of Doom, callback hell, promises, asynchronous programming. Help me out, TypeScript.
So the latest versions of ECMAScript now include the ability to write async functions and do await on promises. This is actually a feature that originated in C#, and it's been very, very popular in C#, and we then proposed a similar design for ECMAScript through the ECMAScript standardization process, and that got accepted into, I think, ECMAScript 2016. And of course, TypeScript supports down-level transpilation of asynchronous constructs because most browsers have not yet caught up with this feature. But if you're using TypeScript, you can pretend that you're on the latest version of ECMAScript, right? Now with async, you get the ability to await promises. And in a sense, what happens when you await a promise is that the compiler turns the remainder of, or the runtime turns the remainder of your function into the callback that you otherwise would have had to pass. So it gives, instead of Pyramid of Doom, you get to just write nice sequential code. You get to use all of the control flow constructs that you use, that you know from sequential programming, right? Mm-hmm. or traditional non-async programming like while loops and for loops and whatever, which you try to write a while loop around something that has a callback, right? And it's like, now you have to write a state machine, and it's horrible. Humans are very, very bad at writing state machines. But compilers and runtimes are very good at it. So in a sense, this is like taking that hard part out of the equation and allowing you to think of the code just in a straightforward synchronous fashion. But then every time you use the await operator, we will arrange to yield, and then control can later come back and continue running in your function without you having to do all of the hard work of arranging callbacks and lambdas or nested functions or what have you.
You promise?
Nice.
Question from Twitter. We get this question a lot, actually, about you. What's your favorite language that you've been a part of?
That's sort of like asking, well, who's your favorite child? You know, I mean, you can't answer that question. I love all of them. You know, I started out in Pascal with Turbo Pascal, and then moved to Delphi, which basically is like Object Pascal or Turbo Pascal with objects and modules, and then when I came to Microsoft, I worked on C#, of course, and now I'm working on TypeScript, and they've all been fun. I mean, I'm fortunate enough to have been doing this now for almost 35 years, you know, and it's always been my hobby. So I've never really held a real job. Is the way I talk to people about what I do, you know. TypeScript is fun because it's different from the others in that it's a transpiler, and it's a type system really more for tooling's sake than for code generation's sake, for example. I mean, it used to be that TypeScript type systems are important because then they would enable your code generator then to understand what kind of code to generate. But that's not really what we're doing with TypeScript. We're doing type checking for tooling and productivity's sake. It also allows you to go in different places, you know, so TypeScript has a lot of novel features in its type system that I haven't seen in any other programming languages. So it's always fun. You don't get a lot of greenfield opportunities like that. So I've been, you know, very happy to work on it. I write more code now than I've done in the past decade, probably. So it's
we all
it's a lot of
appreciate
fun. Oh, so do I.
I'm John Papa.
And I'm Anders Heilsberg.
And we just learned 5 coolest features about TypeScript.